When you use framework like Spring Boot, have you wondered what happens behind the scenes? How a HTTP request just magically appears in your controller? It would be interesting to know how to implement a simple HTTP server. Hi guys, welcome back to my channel. Today we will see how we could implement a very simple HTTP server using plain old Java with only a few lines of code and without using any frameworks. Also, at the end of the session, we will understand how we can also implement and configure a thread pool, compare sequential versus concurrent requests, and test using Apache Benchmark. So let's get started. First, a quick intro about HTTP server. A HTTP server is a software application that listens to and processes requests made by client over Hypertext Transfer Protocol, or shortly called HTTP. The server responds by serving content such as HTML files, videos, images, or simply text documents. For this exercise, I'll be using Java version 23 and IntelliJ IDE. So I will open IntelliJ, click on New Project. Let's name this simple HTTP server. Build system, I can use IntelliJ for this project. It honestly doesn't make any difference, but I will just go ahead and use Maven for now. Okay, so our project is now created. So let's open the directory Java. I'll create a new Java class called simple HTTP server. Let's create a main function. For this exercise, I'll be using Java's two important components, that's socket server and socket. First, what is a socket server? A socket server is a server-side component which listens to incoming connection and accepts a connection. So let's see how this can be implemented. First, let's define a port number. Let's say 8080. Let's make this final. And now let's define server socket. Socket is equal to new server socket. And let's bind this to the port number 8080. So now this is throwing compilation error because it wants us to handle IO exception. I'm going to wrap this around with the try catch block exception. So now the compilation error is gone. And then I say server socket dot accept. So essentially what it's doing is that I'm binding the server socket to a port number and then accepting any incoming connections. So this is our first step. Now let's run this and see how it works. So we see at this moment nothing is happening. That's because we haven't really told the server how to handle this request. So this is where the second component, socket, comes into picture. A socket is an endpoint for communication between two different machines. It provides a mechanism for exchanging messages between client and server. So let's see how we could use this socket for our purpose. So let's define a private static method called handle request. Turns void. And when the server accepts a connection, this returns a socket. Let's import this. And then let's say handle request, pass in the socket. Socket. Now socket has get input stream, that is to read the input, and it also has an output stream where we use it to write the output. Input stream, output stream. Now let's wrap this in try catch block like exception. Let's print here failed to handle request. Now let's read the input using buffer reader. Input stream reader. Reader dot read line. So we say here line dot split. This returns an array parts. So what I'm trying to do here is just parse the first line and split this by spaces. So the first part is actually a request method. We call this request method. And the second part is actually the path. For this exercise, I'll be assuming we are going to send a GET request with a URL path as messages. The server encounters this path messages. The server should just respond with a simple message like hello. So I want to check here if the request method is equal ignore case. I want to check here if the request method is equal to get and the request path is equal to messages. So now that we have mapped our request method and path, it's now time to send a response from the server. Send a response from the server. Let's define a private method here called outstream. And then here, let's define a message. String message is equal to hello from code node. So now let's define HTTP response is equal to HTTP slash 1.1. This is the protocol and version. Here we say 200. Okay, and in the next line we have content type, which is text plain. Content length is, we can see here, message dot length and plus new line character twice message. It's important to provide here two new line character. That's because it's a separation between HTTP headers and body. Okay, now let's write it to output stream, right? HTTP response, we get bytes, stream.flush, stream.close. So now this is complaining about IO exception. Let's throw IO exception, and then we can invoke write response. Also, we have to add here finally socket dot close. Let's wrap this print here. Get message. Also, similarly here we can say here one final step that we have to still implement. That is, when a server is running, we have to ensure that it's running continuously. Essentially, we want our server to be infinitely running and accepting incoming connections. So we add this here in while true, and then say accept and handle request. We can also put a print statement here. Or let's run this server. Server is running at port 8080. Let's send in a request. Hello from Codernaut. Now, with this example, we have seen how we can build a very simple HTTP server without using any frameworks. There are many things which are not considered or not implemented yet, especially handling concurrent requests and security and many other things which are part of a standard HTTP server, such as Tomcat, for example. As a last step in this exercise, I want to test how this server would behave when we send concurrent requests and if we could improve its performance, if any. First, let's see what happens if we send concurrent request. So in order to test concurrent requests, I'm going to use a simple tool called Apache Benchmark. So if you're not familiar with Apache Benchmark, very simple tool used for benchmarking your Apache HTTP server. We can send in requests with concurrency level, and we can also specify number of requests that we want to send in. And this is all that we need. With the latest Mac, Apache Benchmark is pretty standard and it's available out of the box. So all you have to do is type in AB, and you can see here it takes in options and that URL. So in order to test concurrent request example, I'm going to put in a simple thread.sleep. This is to simulate a simple delay in processing requests. So I'm going to say here thread.sleep 1000 milliseconds, and then we can put handle the error and then run the server. Send in the same request again using Apache Benchmark, and then there you go. We see time taken for test is just a little bit more than 10 seconds. And what's important is time taken per request is around about 1 second. If we send in 10 concurrent requests, it takes in like 10 seconds because the messages are being processed one after the other. As a last step in this exercise, I'm going to define a thread pool and see if we could improve the performance of our concurrent requests. Let's see how this can be achieved. So I'm going to define thread pool executor. Pool executor is equal to new thread pool executor. It takes in pool size, and then we have keep alive, let's say 0 for now, and time unit is in seconds, and then new array blocking queue, let's define the size as 50. So we have defined our new thread pool executor. What really is important is the core pool size, which is 4 for this use case. Now let's use this. So all we have to say is execute and copy this here. And that's it. So let's send the request again. You see, it took much lesser time than before. In comparison with the previous one, it's almost 6 seconds faster. Another important point to consider is the thread pool count that I have taken into account. For this particular use case, I set a thread pool count of 4, and we could see there was significant performance improvement. For this use case, it should be okay, but it may not be always so for all use cases. So the thread pool count should be chosen quite carefully based on many factors like what's the available cores in your machine, what kind of activity the server is performing, and various other things. So it's always better to do a little bit of experiment with various numbers before arriving on an optimal number for this thread pool count. Before we wrap this up, I want to emphasize the fact that this is only a simple demonstration of how we can build a simple HTTP server. It's not meant to be anywhere close to the industrial grade web server or a framework like Spring Boot, for example. The goal here is to get a deeper understanding of how this HTTP server could be built from scratch. Thank you all for watching. See you all in the next video.